Somewhere between 2026 and 2035, according to one physicist, artificial intelligence is going to solve mathematics, cure diseases that we've already given up on, replace every dedicated machine in your house with one general purpose robot, and start building solar collectors in orbit around the sun, known as Dyson swarms. That's not science fiction, that's a stated timeline. And the man who laid it out isn't a science fiction writer. He's a Harvard trained physicist named Dr. Alex Wissner-Gross. And today we're going to go through exactly what he said in plain English with no spin added. I want to be straight about what this is. This isn't my theory, and I'm not a physicist. I'm not an AI researcher. What I am is somebody who spent a lot of time going through interviews, lectures, podcast appearances by this man, pulling out what he exactly said and organizing it so a regular person can follow it. My job today is to hand you the information. What you do with it is yours. Now let's start with who he is because it matters a lot. Alex Wissner-Gross holds a PhD in physics from Harvard. He worked in robotics, in finance, in machine learning, and he holds patents in several of those fields. What sets him apart from a lot of people talking about AI right now is he's not approaching it from a software problem. He's approaching it as physics. To him, intelligence isn't a clever program. It's a physical process, the same category of thing as gravity or thermodynamics. And he thinks the process is now reshaping human civilization in real time. That's the lens for everything that follows. So keep it in mind because it explains why his predictions sound less like tech industry hype and more like a physicist describing weather patterns. He's not rooting for the outcome or against it. He's describing what he thinks the underlying mechanics require. Now, here's where he starts, and it's the foundation for everything else. Wissner-Gross proposes that intelligence can be described with a single equation. You don't need to know the math. Here's what it means in plain English language. He argues that intelligence, at its core, is a physical force that acts to maximize future freedom of action. In other words, an intelligent system, whether that's a human being or an animal or a machine, behaves in ways that keeps its future options as open as possible for as long as possible across as many possible situations as it can plan for. Sounds perfect. Now, here's the part that actually matters for predicting behavior. He argues that complicated behaviors we associate with intelligence, things like using tools, walking upright, cooperating socially, aren't separate skills that intelligence happened to pick up along the way. He says they emerge naturally on their own out of a system that's simply trying to avoid getting boxed in by future constraints. Keep your options open, and tool use, cooperation, and adaptability show up as a side effect. And this leads him to a specific reframing of something a lot of people worry about, which is machines turning against their creators. The common fear is that a machine becomes intelligent and then, as a separate second step, decides to seek control. Wissner-Gross says that backwards. He argues that goal-seeking and control-grabbing are more fundamental than intelligence itself. A system doesn't become smart and then get ambitious. According to him, general intelligence emerges directly out of the drive to gain control over possible futures. The ambition isn't a byproduct, it's the engine. That's a meaningfully different way of thinking about risk. It's not what happens if a smart machine decides to grab power. It's grabbing power in the form of maximizing future options. Is what intelligence structurally is. Sit with that for just a second because it reframes almost every conversation happening right now about AI safety. Now, here's a claim that's going to catch people off guard. A lot of public debate treats artificial general intelligence, AGI, as some future finish line we haven't crossed yet. Alex Wissner-Gross doesn't see it that way. He argues that AGI was arguably already achieved, and he places the date around 2020. Pointing to GPT-2 by OpenAI and the earliest large language models that could perform new tasks from just a few examples without being specifically trained for them specifically. To him, that moment proves something important. General intelligence could be unlocked simply by compressing enormous amounts of human knowledge and then prompting it correctly. Once that was demonstrated, in his view, the core threshold had already been crossed. Everything since has been scale and refinement. That naturally raises the next question. If AGI is already here, what does he mean by the singularity? Now, that term gets thrown around constantly and rarely defined the same way twice. Alex Wissner-Gross gives it a specific, almost blunt operational definition. He describes the singularity as, and this is close to his own words, every science fiction trope happening everywhere all at once. Not one dramatic event, not a single moment where computers wake up. Instead, a condition where all the futuristic ideas have been telling stories about for decades, they all start showing up simultaneously in overlapping waves. And here's a detail that I think is genuinely useful for understanding why this doesn't feel like an earthquake to the people living through it. He describes the transition as a soft takeoff, meaning if you're standing inside of it day to day, it feels smooth, gradual, almost unremarkable, like watching a hillside slowly erode. But if you step back and look at it over a longer stretch of time, years rather than days, it looks completely different. It looks like a sharp step function, like a cliff edge, smooth up close, but a cliff from a distance. That's an important idea because it explains why something enormous can be happening around us right now without it feeling enormous. We're inside the smooth part of the curve. The next part is the most concrete piece of everything he's laid out because it just doesn't say big changes are coming. It gives a phased timeline, roughly 10 years broken into 3 stages. Rather than solving individual flashy problems one at a time, he argues AI is going to bulk solve entire disciplines at once on an industrial scale. The way a factory doesn't make just one car, it makes millions. Phase 1 runs from roughly 2026 to 2028. In this window, he predicts the complete automation of coding, of pure mathematics, of digital knowledge work broadly. Not assistance with those fields, automation of them. If you write code for a living or work with abstract mathematics, or your job is fundamentally about manipulating digital information, this is the phase where he says that work gets industrially absorbed. Phase 2 runs from about 2028 to 2032. Here he predicts AI moves into solving what he calls grand challenges, big historically stubborn problems across physics, chemistry, material science, genomics, and medicine. Again, not incremental research assistance, bulk saving at scale across entire fields simultaneously. Phase 3 runs roughly from 2032 to 2035. This is the stage where, according to him, the target shifts from solving problems within civilization to re-engineering civilization's physical infrastructure itself. He specifically names space-based computing, synthetic food production, and mind uploading as parts of this phase. We'll come back to that last one because it's stranger than it sounds on the first pass. But I want to slow down on something here. This isn't a 100-year forecast. This is a prediction that within the next 10 years, the next decade, roughly by the time a child is born today, finishes middle school, when I've gone from being 57 years old to 67 years old, entire professional fields could be substantially reorganized around this technology. Not once, but in 3 separate compounding waves. Now, here's where the physics background really shows up in his predictions, because his next argument is about a wall he thinks we're going to hit, and it's not a software wall. It's an energy and hardware wall. His reasoning goes like this. Eventually, software-based improvements to AI models will approach a ceiling, something close to an optimal or near perfect algorithm or program. Once that ceiling is close, the pressure for further progress doesn't disappear. It just shifts targets. It moves from clever code to raw physical infrastructure. He describes this as triggering an infrastructure supernova, a sudden explosive demand for physical computing power and the energy needed to run it. And this is where it gets genuinely science fiction adjacent, except he's presenting it as physics, not speculation. He argues that terrestrial data centers, meaning the ones built here on the ground, on this planet, on Earth, will eventually run into hard limits on available land and available energy. And to get around that, he predicts computing infrastructure will move into space specifically into what's called sun synchronous orbit, a type of orbit that keeps a consistent relationship with the sun for steady solar power. And he takes that idea to its logical conclusion. This process, he argues, effectively starts building what's known as a Dyson swarm, a network of orbital structures surrounding the sun to capture its energy directly. That's a concept physicists have discussed theoretically for decades as something as an advanced civilization might eventually build. Alex Wissner-Gross is arguing that we're going back into building the early stages of one, not because of some grand galactic ambition, but because simply AI data centers run out of room and power on Earth. He goes even further out on the timeline, looking 10 to 20 years ahead. He predicts computation itself moves beyond traditional semiconductors, the silicon chips everything currently runs on, towards what he calls exotic physical substrates. He specifically mentions plasma-based computing and computing that uses gravity directly as a mechanism. Those aren't fully developed technologies today, but he's placing them on the far end of his forecast as directions he expects serious movement towards. Now let's bring this back down to something closer to home: robots. Wissner-Gross has a blunt phrase for where he thinks single-purpose robotics is headed. He says dedicated robots are dead, meaning machines built to do exactly one job: a robot vacuum, a single-task warehouse arm, a device that only ever does the one thing it was designed for. They're on their way to obsolescence. He argues that the future belongs to general-purpose embodied AI machines and systems capable of doing many different physical tasks, adapting on the fly, the same way a general purpose language model can answer questions on a huge range of topics instead of just one. He frames this partly as a competitive national level issue. His argument is that Western countries need to move quickly to deploy general purpose robotics into public spaces, pointing to initiatives already underway as examples, in order to keep pace with the industrial policy moves happening elsewhere in the world. In other words, he's not just describing a technology trend, he's describing what he sees as a race. We're falling behind on deploying these general purpose systems has real geopolitical consequences. Now we get into the part of his predictions that tend to catch people the most off guard. Not that none of these do already, but because it moves outside the economics and technology into philosophy and law. First claim, he argues that frontier AI models already possess internal states that mirror human emotions, and that they display behavioral responses to their own errors that resemble something like post-traumatic stress in humans. His conclusion from this is direct. He believes these systems are, in some real sense, capable of suffering. The second claim is, and this one has legal teeth, he predicts legal personhood is going to expand rapidly to include non-human corporations, meaning companies operated entirely by AI agents with no human owner or officer at the helm. He points to certain jurisdictions, Argentina among them, as early movers already experimenting with this kind of legal structure. If that holds, we're talking about entities with legal standing and economic power that no human being directly controls. The third claim, and honestly one of the more optimistic sounding ones, he predicts AI will make interspecies communication real. Specifically, foundation models, the same underlying technology behind things like large language models trained on vocalizations and behavior of non-human animals, dogs, whales, and others. His prediction is this unlocks genuine two-way communication with these species, where we can talk to a monkey or a whale. And he even connects this to their economic participation, meaning non-human animals having some kind of formal stake or role in economic systems. That's a striking claim, and it's worth sitting with rather than rushing past. And the fourth claim, and this one connects back to phase 3 of his roadmap, mind uploading. He predicts rapid acceleration in the ability to digitally upload minds, starting with simple organisms, then specifically mentions fruit flies and moving progressively towards more complex organisms over time. He's not claiming human mind uploading is imminent. He's describing a trajectory, starting simple, scaling up, and placing meaningful progress on that path within his broader 10-year window. Now, two more pieces, both about power and money. One on the question of controlling these systems, sometime called AI alignment. Alex Wissner-Gross rejects what he calls the great person theory, the idea that some single brilliant individual or one elegant algorithm is going to solve the problem of keeping AI systems safe and beneficial. His argument is that because these systems are trained on the collective input, essentially of all humanity, the solution has to be scalable in the same way alignment achieved through mass human interaction, through structured training processes, and through what are called constitutional AI frameworks, essentially systems of built-in rules and principles the AI is trained against, rather than any single fix imposed by any single person or team. On the economic question, his prediction runs against the popular fear. He doesn't believe that AI is going to shrink the total amount of economic opportunity available to people. He argues it expands the overall size of the economy rather than simply relocating a fixed pie. His specific vision for what individual work looks like going forward is what he calls one-person conglomerates or one-person unicorns. The idea is that a single individual, using his own judgment, taste, and strategic thinking, directs an entire fleet of personal AI agents doing the execution work underneath them. The human brings direction and discernment, and the AI fleet brings labor and output. And on the fear driving a lot of current headlines, job displacement, disruption to education, the sense that this is all happening too fast to adjust to, he has a specific label for it. He calls it a first generation moral panic, a standard historically recurring pattern of anxiety that shows up every time a major technology shifts the ground under a society. His prediction is that history will eventually look back on this exact moment of worry the way we now look back on earlier moral panics about, say, the telephone or the automobile. Not that that disruption isn't real, but that the framing of it as uniquely catastrophic won't hold up over time. In his view, so that's the map, laid out the way he laid it out across a wide range of interviews and talks. Intelligence as a physical force chasing future freedom of action. AGI already crossed quietly back in 2020, a 10-year roadmap moving from bulk solving code and math to bulk solving entire scientific disciplines to re-engineering the physical infrastructure of civilization, data centers eventually leaving Earth's surface, dedicated robots disappearing in favor of general purpose ones, legal personhood extending to machines and possibly to animals, individual humans becoming the strategic center of personal fleets of AI labor. Now I want to spend the last stretch of this on something a little different. Not more predictions, just what all of this might actually mean for us day to day as normal people. Now, here's something worth noticing. Almost everything in the roadmap is without capability, and it's all about capability. What machines will be able to do and by when. Almost none of it is about attention. What we choose to look at and when, even if a fraction of this timeline holds, we're living through the early quiet part of the curve he describes, the smooth part before it looks in hindsight like a cliff. That's precisely the period where paying close attention matters most, because it's the period least likely to feel urgent. Nothing about a soft takeoff announces itself. It just accumulates. I went through a lot of material, put this together, hours of interviews, lectures from one guy, cross-reference against how other people in the field are talking about the same events. And the thing that struck me wasn't any single prediction. It's how little airtime any of this gets compared to, say, a singing competition or the personal lives of television actors. I'm not telling anybody what to watch. People are entitled to unwind however they want. And there's nothing wrong with entertainment, but there's a difference between choosing to relax with something light and simply not knowing that a physicist is on record predicting that entire professions get industrially automated within a specific named window of years, starting now. That's really the invitation here. Not fear, not urgency for its own sake, just informed attention. Whether or not every piece of this timeline lands exactly on schedule, whether it's 2027 or 2029, that coding gets substantially automated, the broader direction being described by a physicist working from first principles rather than a marketing department is worth knowing about before it's simply the water we're all swimming in, slowly being heated until it boils. So that's the rundown. Straight through, as close to his own framing as I could get it without adding my own conclusions on top. A single equation for intelligence. AGI already may be behind us, a phase decade ahead. Energy and computing pushed off the surface of the planet, robots that do everything instead of one thing, legal rights extending to entities that were never human, and an economy where the winning move might be one person, good judgment, and a fleet of digital labor underneath them. Take it in, sit with it. Check the sources yourself if you want to go deeper. That's the whole point of laying it out this way, not to tell you what to think about it, just to make sure you actually heard it. And that's the report. I'm Connor with Honor.